Hello teachers, welcome back to section 4-1 where we're spending our time talking about divisibility tests, and we have a problem right here. Determine whether 1002 is divisible by 3 and 9. Now I could just rehash the divisibility test very quickly to test if a number is divisible by 2. You know what to do. Divide it by 2. If the remainder is 0, then it's divisible by 2. By 3, we sum up the digits, and if the sum is divisible by 3, so is the original number. That is true with 9 as well. You sum up the digits, and if the sum is divisible by 9, then it's divisible by the original number. Now 3 and 9 are the only ones that you want to sum up the digits in this way. If a number is divisible by 4, it's divisible by, the last 2 digits are divisible by 4. You know the rule for 5, right? The units place is a 0 or a 5. The rule for 6, I don't believe we talked about yet, so I'm going to withhold that thought. The rule for 8 is the last 3 digits are also divisible by 8. The rule for 9, we just rehashed. The rule for 10 is the units place is a 0, and we're going to learn a rule for 11 as well. But here we're focused on 3 and 9. So what do we need to do? We need to sum up these digits. So 1 plus 0 plus 0 plus 2 is equal to 3. And 3 divides 3. Therefore, you ever see these 3 dots like this in a triangle? That does mean therefore 3 divides 1002. Great rule. Have it typed up for you because 1 plus 0 plus 0 plus 2 is equal to 3. 3 divides 3 and 3 divides 1002. You know what I didn't do? I didn't check 9. But I blasted up the answer before we even checked 9. Now again, you add the digits together and you get 3, right? But 9 doesn't divide 3. So 9 has to go into the sum for this to be divisible by 9. Therefore, if I use proper notation, 9 does not divide 1002. Another example, determine whether 14,238 is divisible by 3 and 9. Let's try it again. You pause it. You do these two. All right, what'd you find out? Does it divide both of them? Does 3 and 9? Let me ask that again. Does 3 divide 14,238? Does 9 divide 14,238? What did you find out? Let's do this real quick. So 1, let's get my pen working real quick. There we go. So 1 plus 4 plus 2 plus 3 plus 8. So the sum of all 5 of these digits, we know 1 plus 4 is 5, 5 plus 2 is 7, 7 plus 3 is 10, and 10 plus 8 is 18. So that's the sum. Now 3 does divide 18. In other words, when you do 3 dividing it into 18, you get a 0 remainder. So 3 divides 18. Therefore, we know that 3 divides 14,238. No calculator required, right? Does 9 divide 18? Yes, indeed it does, right? 9 divides 18 2 times. Therefore, 9 also divides 14,238. And I do have that typed up for you nicely. And it's exactly the same result. Yes, 3 and 9 divide those numbers. I have a fun example for you here. The store manager has an invoice for 72 calculators. The first and last digits on the receipt are illegible. Probably went through a printer like mine in my office. You can't read it hardly at all. There's some big nasty line going through each of them. But the manager can read that it's something in the hundreds place, 67 and 90 something cents. We just don't know the hundreds place and we don't know the units place. So what are the missing digits? Is this something we can figure out, do you think? And what is the cost of each calculator? So what in the world could we do to determine these digits? Well, you know what? Divisibility test to the rescue. Let's see if we can use divisibility test to solve this problem. Now, what do we know? We know that 72 needs to divide into this value, right? So let's think about this. And let's do some algebra. You want to? I mean, you could leave those big black spots if you wanted to, where the line goes through them, or we could talk about this in terms of replacing the hundreds place with the x, and then the units place over there, which is not really the units place. It's like cents is what I'm thinking about, with y. Okay, and remember we talked about 72 calculators are sold, so this number must be divisible by 72. This is the key. Now tell me, or at least in your mind, send me the message, what does that mean if a number is divisible by 72? What does that really mean? Well, it means it's divisible by 9, right? Because 9 divides into 72. And it's also divisible by 8, because 8 divides into 72. Now it also means it's divisible by 3, it's divisible by 2, it's divisible by 4. But the 9 and the 8 are the most restrictive. What's the test for 8? Remind me, what is the test to determine if a number is divisible by 8? Well, remember the last 3 digits are also divisible by 8. Hey, that might take us a long way. What are the last 3 digits? Look, 7, 9, and then y. Let's use that information, and I'm going to skip to a typed up page for you. There we go. We've already discussed this. 72 equals 8 times 9. The amount is divisible by both 8 and 9. Let's keep going. For the number on the invoice to be divisible by 8, the 3-digit number 79 something must be divisible by 8. So you could play around with this, really. You could check 791 to see if it's divisible by 8, 792, and you keep going, 793, just with your calculator. Or you could do long division, but this is one of those where I think it might be worth grabbing your calculator, but you could always divide this. So in my calculator, in case you don't have one on you, 791 divided by 8 gives me a decimal, 98.875. So we have a remainder here. What about 792 divided by 8? Hey, right there, it goes 99 times. I could keep checking, but I found it. 792 is divisible by 8, and you're going to have another 8 later before the number is divisible by 8. Therefore, 792 is the only one that's 79 something that's divisible by 8. You see what I mean? Because you're not going to have another number divisible by 8 until 8 units later. So 792 is our winner. So y must be 2. Okay? There it is right there. It tells us y must be 2. What does that mean we have so far? Well, back to our original blocks up here. So we have, this is a 2. Now we got to focus on the hundreds place number. Maybe we could use the fact that this number is divisible by 9, right? So if a number is divisible by 9, what do we know, right? Here we go. Because the number on the invoice must be divisible by 9. Hey, you add them all together, and it has to divide by 9, right? So if I add all these numbers together, x plus 6 plus 7 plus 9 plus 2, because we don't know that the x is, of course, what we're looking for. And this is x plus 24 when I add, again, 6 plus 7 plus 9 plus 2. Now, we need that number to be divisible by 9. Is 24 divisible by 9? Well, no. Y'all, what's the next number that's divisible by 9? 27, you say? You bet. So 27 is divisible by 9. Well, if x plus 24 has to equal 27, doesn't that mean x is equal to 3? That would work, right? And I've got that typed up for you too, since 3 is the only single digit that will make x plus 24 divisible by 9, then x is 3. And then you go back and you fill in the blanks, then we know the number on the invoice must be $367.92. But you know what? That's not all it asked. It also asked how much would each calculator cost. And remember, if we know the total invoice is $367.92, and we bought 72 calculators, you know what to do. We take $367.92 and divide that by 72, and that results in, stand by while I type this on my calculator, $67.92 divided by 72, and I get $5.11 per calculator. That's a pretty good deal. Maybe they're not super fancy, huh? Okay, and then there it is summarized for us. So, more on divisibility tests. A whole number, you're going to love this one. A whole number is divisible by 11 if and only if the sum of the digits in the places that are even powers of 10 minus the sum of the digits in the places that are odd powers of 10 is divisible by 11. You want me to show you an example of that? Before we dive in deep with this, let me show you an example. It's not nearly as bad as that reads. Okay, look at this number. We've got 35,365. Okay, now when I read this again, we're just going to see if this number is divisible by 11 without playing with our calculator. We're going to do this by hand, and I'm not going to do long division by 11. I'm going to do what this says. So it says if the sum of the digits in the places that are even powers of 10. Y'all, what's even powers of 10? Remember, this place value is 10 to the 0. This place value is 10 to the first. This one is 10 to the second. This one is 10 to the third. And this one is 10 to the fourth. And it says if the sum of the even powers, so that's an even power because it's 0. That's an even power because it's 10 squared. That's an even power because it's 10 to the fourth. Notice it's every other one. So if we add those digits together, 3 plus 3 is 6 plus 5. That happens to be 11. Minus, and then it's saying minus the odd power, the sum of the digits in the places that are odd powers. So that's these other guys, the 6 and the 5. Notice that when I add 5 plus 6, that happens to be 11. When we do the difference, we get an answer of 0. Now, does 11 divide 0? Does 11 divide 0? Yes, you're really, remember the calculation you're doing is 0 divided by 11. That is okay. What is not okay is does 0 divide 11. 0 doesn't divide any number. Remember, that's undefined. But 11 does divide 0. So if your sum over here is 0 or 11 or 22 or 33 or 44 or 55, all the problems I've done are most of them are 0 or 11. If you get any number that's divisible by 11, including 0, then you could say, yes, this number is divisible by 11. And then I've got one more test for you. An integer is divisible by 6 if and only if the whole number is divisible by both 2 and 3. We know the test for 2. The units place is an even digit, so 0, 2, 4, 6, 8. And the test for 3, you sum up the digits. And if the sum is divisible by 3, then so is the original number. All right, I got a ginormous number for you, right? If we were to read that number, remember at the very end, the 583, that's like the ones, tens, hundreds place. The next group is the thousands group. And then we have the millions group, yes, and then the billions. So this number is 57,729,364,583. That is that number, okay? So we're supposed to determine whether that huge billions number, actually 10 billion, right, is divisible by each of these numbers. So we're going to do the divisibility test. My advice is to pause it, do this yourself, make sure you're okay with it, come back, see what kind of answers you get. All right, so is this divisible by 2? Does 2 divide that? And I'm going to say no. Why not? No. We need to back it up. 2 does not divide 3. You're looking at just the ones place down here. Does 3 divide it? Well, let's take the sum of each of these numbers. So 5 plus 7 is 12. 12 plus 7 is 19, right? 19 plus 2 is 21. Add a 9 again, that's 30, 33, 39, 43, 48, 56, 59. I'm going to stop and check that again. And I did verify that that's 59. So here's the question. Does 3 divide 59? If 3 divides 59, then 3 divides our number. Does 3 divide 59? Well, you could just check and add again, right? 5 plus 9 is 16. 3 doesn't divide 16. 3 doesn't divide 59. So the answer is no. 3 does not divide our big 57 billion number. 5. And once again, we would say no, right? Why? Because you're just looking at the ones place, and it's not a 0 or a 5. So not 0 or a 5. So no, 5 doesn't divide it. Does 6 divide it? Well, real fast, no. How do I know so fast? Because 3 doesn't. That's enough all by itself. 2 doesn't either. It only takes one of them to break that rule. So 3 doesn't would be just enough, or 2 doesn't would be enough. Does 8 divide it? So what you're asking yourself is, does 8 divide 583? Now here real fast. I know 8 doesn't divide it because 2 doesn't even divide it, right? If 2 doesn't divide it, y'all, there's no way in the world 8 is going to divide it. So this answer is no. Does 9 divide it? Well, does 9 divide 59? Nope. As a matter of fact, if 3 doesn't go into that number, there's no way 9 is going to go into that number, because 3 is a divisor of 9. And if 3's out, 9 is out. Does 10? You would say no. Why no so quickly? Because there's not a 0 in the units place, right? You got to have a 0 in the units place. And finally, does 11 divide that large number? Now, we got a little bit of work to do. Remember, we've got to add up the even power, or the even positions. 10 to 0, 10 to the second, 10 to the fourth, 10 to the sixth. I have them highlighted, so it's the ones place, the hundreds place, the 10,000s, the millions, the 100 millions, and the 10 billion. We're going to add all those together. I got 5 plus 7 is 12, plus 9 is 21, plus 6 is 27, plus 5 is 32, plus 3 is 35. Again, check me there. I'm going to check myself again in a minute. Then I'm going to add up the 10 to the odd power. So 8 plus 4 is 12, plus 3 is 15, plus 2 is 17, plus 7 is 24. When I subtract, 35 minus 24 is 11. Does 11 divide 11? You bet. So it looks like to me the only yes answer is the last one. All the others were no. And then I got my little cheat sheet coming up right here. Look there. No, 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 all the way across the board until we get to that fancy 11 one. Pretty cool, huh? And that one is yes. I've got one more problem, although it's broken down into parts A, B, C, and D, and then we can wrap up this video. And the problem I have for you here is directly from the homework. So we're justifying each of the given statements in parts A through D. And here I just have question A, okay? They want us to justify that 26 divides 13 to the 6th times 1,000. That's a lot to think about, right? 13 to the 6th times 1,000. Now, how does 26 relate to 13 to the 6th times 1,000? What we really need to know is 26 one of these factors over here? Is there anything that we can do with this 13 to the 6th times 1,000 to pull out a factor of 26? And you know what there is? 13 to the 6th means there's means there's 6 13s. 1,000 is 2 times 500. Where's there a 26 in there? Watch this. I'm going to write this as 13 to the 5th times 13. Notice I pulled one of them down. I'm going to write 1,000 as 2 times 500. And right there, that is 26. So we know for a fact that 26 does, yes, divide 13 to the 6 times 1,000 because we managed to pull out a factor of 26 from the other factors. And then that's an easy way to do that. Now we've got to justify it. Which one is correct? Well, look at this breakdown down here. There's our 13 times 2. There's our 13 to the 5th, and there's our 500 right there, just written in a different order. So D is the answer to this one. And again, I've got a couple more of these that are very, very similar. All right, so the next problem wants me to justify that 13 does not divide 3 to the 7th times 5 to the 4th times 26 plus 1. Now, how could we do this? Okay. Now, what do you think? 13 does divide this one. How do I know that? Well, I can say 13 does divide 3 to the 7th times 5 to the 4th times 26 is really 13 times 2, right? So there it is. 13 is a factor of this first one. But you know what? 13 is not a factor of the 1. And for 13 to be a factor of this sum right here, oops, not a factor, not, then it would have to be a factor of both of these, and it's just not. So how do we justify that? Well, I'm looking for similar work here. 13 does divide the first one. It doesn't divide the second one. They didn't write out this 13 for us, but we're really supposed to recognize that. So I say this is A. I know it's not B because, look, they're saying 13 doesn't divide either of them. But I do know 13 divides the first one because I pulled out a factor of 13. The second one says 13 does not divide 3 to the 7th times 5 to the 4th. That's true, but there's still a 26 there that it does divide 13. Oh, well, look, 13 divides 26. Maybe what's a better answer? Let me erase this. Is this not a better answer? 13 doesn't divide 3 to the 7th, 5 to the 4th. 13 does divide 26, and 13 divides 1. I still think this is the better answer. I don't like that answer. Oh, that says 13 divides 1. It doesn't divide 1. So C is definitely out, and it's because of this issue. Okay. And then the last one says 13 does not divide the first one. It does because of the 26. And 13 does divide 1. That's not true either. So both of those were false. Okay. Let's do another one. All right. What do we got here? Okay. It says we're supposed to justify that it doesn't divide again. So 2 to the 4th doesn't divide 2 times 4 times 6 times 8 times 29 to the 4th plus 1. So we've got to consider these separately. So the question is, does 2 to the 4th divide this first set, 2 times 4 times 6 times 8 times 29 to the 14th? And does 2 to the 4th divide 1? Well, look, y'all, 2 to the 4th does not divide 1 at all. Right? If you divide 2 into 1, we've got a problem. We've got a fraction, and that's not within the whole number, so it doesn't divide it. All right. Does 2 to the 4th divide this? We've got to figure that out. Now, I've just got to find a 2 to the 4th over here somewhere. Now, I have a 2 right here. Hey, I have a 2 squared right there. And right here, I have a 2 times 3. This is 2 to the 4th, because it's 2 to the 1st times 2 to the 2nd times 2 to the 1st. That is 2 to the 4th. So it does divide the first term. It does not divide the second term. Okay, so let's find that answer. Notice on A, 2 to the 4th does not divide the first one. Yeah, it does. So I know A and D are out because it's saying that 2 to the 4th does not divide it. Okay, now here, 2 to the 4th divides the first one. But they've got that split up into not 29 to the 4th. No, 29 to the 4th is not the issue. C says 2 to the 4th, it does divide the first one, but 2 to the 4th does not divide 1. So we're going with C. I'm going to try this one more time. I encourage you to pause the very last problem we're doing together. See if you get the same answer I do. Pause it, try it, come back. All right, so what in the world are we doing? 2 to the 4th, 10 to the 4th, plus 6 to the 4th. Now, if we can figure out if 2 to the 4th divides 10 to the 4th, and 2 to the 4th divides 6 to the 4th, we will have justified that 2 to the 4th divides the sum, because it has to divide both of them. It can't just divide one or the other. It has to do both. But is there a 2 to the 4th in that 10 to the 4th? I argue that there is, because watch. 2 to the 4th, I can write 10 to the 4th as 2 times 5 to the 4th, which we know, properties of exponents, that's 2 to the 4th. I can write as 2 to the 4th times 5 to the 4th. There it is right there. There's our 2 to the 4th. All right, now let's check the other one. Is there a 2 to the 4th over here? Well, let's check it out. Does 2 to the 4th 6? I'm going to write it as 2 times 3 to the 4th. Hey, let's use that exponent rule again. Is 2 to the 4th. Divide 2 to the 4th times 3 to the 4th. Well, sure does, because 2 to the 4th is one of the factors of 6 to the 4th, which we wrote as 2 to the 4th times 3 to the 4th. So this bottom line justifies it. Now let's see if that's one of our options. So 2 to the 4th plus 6 to the 4th equals 2 to the 4th times 5 to the 4th plus 3 to the 4th. Is that true? That looks sort of like what we did, right? Here's what they did. Oh, wait, 2 to the 4th divides 10. Let's just check the others. 2 to the 4th divides 10. Not true at all. 2 to the 4th divides 6. No, that's not true. As a matter of fact, 2 to the 4th is 16. 16 does not divide 10, and it does not divide 6. So B is out. 10 to the 4th plus 6 to the 4th equals 2 times 5 to the 3rd plus 3 to the 3rd. That's not true either. That 5 to the 3rd is 125 times 2. This is, no. Okay. 2 divides 10 and 2 divides 6. Now, D is true, but that's not at all why our problem is true. If we look back at this result, check out the way, I didn't write it that way, right? I was trying to justify it like the previous problems. But here's what they did. They wrote 10 to the 4th plus 6 to the 4th. They replaced 10 to the 4th like we did with 2 times 5 to the 4th. They replaced 6 to the 4th as 2 times 3 to the 4th. Then you could use that exponent rule. It says that's 2 to the 4th times 5 to the 4th plus 2 to the 3rd. To the 4th, my bad, times 3 to the 4th. And they factored out this common 2 to the 4th. This is a distributive property move, right? The 2 to the 4th comes out front, and that leaves 5 to the 4th plus 3 to the 4th. And that's exactly what they have in A. You will get a problem very similar, if not identical. I hope it's similar. And I hope this helps you out. If you have any questions about divisibility tests or anything else, please reach out. I hope you have a wonderful day.